there is one last thing that I have to fill out, and that is what is the flooding scope for type 7 LSAs. And the flooding scope is area, just like with most of the other LSAs. So this pretty much concludes this particular table, but we have one more to fill out. Now, this other table that we are going to be working on is going to be the table that deals with OSPF area types. So the way this table is going to work is I want to pay a great deal of attention to the behavior of the default route in OSPF, because default route in OSPF is something that is an area of concern for many students, because it's not exactly straightforward the way default route behaves in OSPF. So here we are going to list what is the possible area, what are the possible area types, what can they be. We are going to look at what are the LSAs allowed in this area, and then we are going to see the behavior of the default route. Can we have the default route in this type of area? Can we generate the default route only into that area type without actually affecting any other areas? Is it generated by default? That means when I create this area type, is the default route going to be generated by default without any intervention? And when we generate the default route, how do we generate it? And what type of route is it going to be? Is it going to be carried by type 1 LSA, type 2 LSA, 3, 4, 5, 6, 19, whatever the LSA type might be? So let's start with that. So the first area type is the normal area, which actually includes the backbone areas as well. And the allowed types are 1, 2, 3, 4, and 5. And the default route is allowed to exist, but it cannot be generated only into this one area. So when you are creating a regular area or the backbone area, you can have a default route in that area, but you can't have the network that, for example, has two areas, like say area 0 and area 5, that are both normal areas, and you say that, okay, I'm going to have default route in area 5, but I don't want it in area 0. You cannot do that easily. It's not supported by default. You can do some sort of filtering there, but it is going to be not doable by just virtue of creating the area and telling it in this area inject the default route. This is not something that you can do. Now, when you create the normal area or the backbone area, the default route is not generated by default. But what you can do is you can create an area. Actually, let me not type the whole thing. You can create a default route if you are using default information originate, and you can have this always keyword. Now, this is a very important thing to understand. What default information originate will do, it will implicitly redistribute an existing default route. So the router is, when you configure this in the OSPF process, what the router is going to do is it's going to look at the current routing table, and it's going to determine, does it have a default route? If there is an existing default route, no matter what the source is, that default route is implicitly going to be redistributed into OSPF. So this becomes an external routing information. If you do not have the route, the default route in the routing table, when you type default information originate, you are not going to have a default route inserted. If you want to inject the default route without it existing prior to this moment from other sources, you have to use the always keyword. When you use default information originate always, the OSPF will generate the default route, and it will be inserted as type 5 LSA. So let me just put type 5 here. So the next area type that we have is the stub area. In stub areas, we can have LSAs type 1, 2, and 3. Stub areas do not allow presence of external routes, so type 5 and type 7 are not allowed, and type 4 would be completely pointless, so it's not allowed. The default route can exist in a stub area. It can be generated only into the stub area, so when you create a stub area, you can tell the router generate the default route here and don't affect other areas, and it is actually generated by default. And the command to do that is area X, whatever the X is, and you're going to say stub. So by virtue of creating the area, we are going to generate the default route. And the default route that gets generated is going to be inserted as type 3 LSA. The next area type is total stub. And this is where I have to write something down in the whiteboard. Total stub is the same area type as the stub. There is no difference between these two. Total stub only implements additional filtering. The reason why I'm saying this is that you could be faced with a task in your lab that says, create area 155 and do not make it stub. And then there are certain instructions and you realize that making this a total stub would actually solve your problems. And you say, oh, I'm not going to make it a stub, I'm going to make it a total stub. You just failed the task. Because when the task says, do not make it a stub area, that means do not make it a stub area. Total stub is a stub area with additional filtering. To illustrate this, I'm going to use a network that by now may look a little familiar. So I'm going to have 4 routers interconnected like this. Now, these are my ABRs. So this is going to be R1, R2, R3, and R4. Now I'm going to have 2 loopbacks on R1. So this is going to be loopback 0, and this is going to be loopback 1. Now, this is going to be area 0, and this is going to be area 2, 3, 4. Now, this is going to be the configuration on area 2, 3, 4 on R4. So I'm going to say router OSPF 1. I'm going to say area 2, 3, 4 stub, and then assume that there are network statements in place, but save me the trouble from actually having to type them out. So this is the configuration here. Now, the configuration on my, let's say, the configuration on my R3, let's say it's this, and let's say that this is the configuration on R2. So we can see here that R4 was configured to have area 234 configured as stub. R3 has area 234 as stub, but this one here has it as total stub. Now, am I going to have a valid adjacency here? The answer is yes. Am I going to have a valid adjacency here? The answer is yes. Now, let me explain why this is significant. Let's say that loopback 0 was advertised in area 0 as an internal route. That means it is going to arrive here as type 1 LSA, and it's going to arrive here as type 1 LSA. Now, both R2 and R3 are generating the default route. Why are they generating the default route? Because this is what stub does. Now, R3 here is actually going to be injecting the path to loopback 0. So let's say that the address here was 1111 and that the address here was 11, 11, 11, 11. So what I'm going to be getting from this router here is also 1111/32, but this will not be injected from this side here. Why is it not going to be injected? Because of this no summary means that no type 3s will actually be allowed. Well, no type 3s except for one. This type 3 is actually allowed to go in, but no other type 3s are going to go in. So this one here is going to be filtering the path to 1111. So the actual path that the traffic to 1111, if I did a trace route from R4 to 1111, the path will take me this way. So this is the way I will reach 1111. But let's say that I actually redistribute this into my OSPF. So this is now going to be advertised to R2 and R3 as type 5 LSAs. Now, type 5 LSAs are not allowed to go into the stub area. This is what stub area does. It does not allow type 5 LSAs. But because I do have a default route here, if I am to reach 11, 11, 11, 11, the path will actually be load balanced. Now, two things to take out of this. One is that router configured as stub here actually will form an adjacency with the router that is configured to be no stub. And the second one is, please take a very, very close attention at what got advertised here and what got advertised here. This is something that you need to know and understand fully when you go to the lab, because this could cause you to not pass the exam. So what is allowed in a total stub area are type 1, type 2 LSAs, and I'm just going to indicate here that some type 3s are actually allowed, and this is going to be the default route. The default route is allowed. You can inject it directly into the area. It is generated by default, and it will be type 3 route. And the configuration is area X, stub, no summary. The next area type is the NSSA, and in the NSSA area we are allowing types 1, 2, and 3, and 7. Types 4 and 5 are not allowed. The default route can be is allowed in the area. It can be injected directly into the area, but it's not injected by default. If we inject it, and the command for that is area X NSSA default information originate. Now, I might have gotten the dashes wrong here, so don't hold it against me. It is something that you would just type def and then tab. I really can't remember the dashes, and if I try to remember all the dashes that are in use in iOS, I would go crazy, because that's consistency of iOS, especially their use of dashes. So when you enter this, what is going to be injected is going to be type 7 with the default route. And similarly to a total stub, we have a totally stubby, not so stubby area, so totally stubby NSSA. And similarly to the previous example, what we are allowing here are types 1, 2, 3, and 7. Now, the only type 3 that is being allowed is the default route. All others are being filtered. And the default route is allowed. It can be generated into the area, but in this case, it is actually injected by default. And there are two ways of doing it. One is if you do area X NSSA no summary. If you do this command, what you are going to get is type 3 default. But you can also do something like this. If you do area X NSSA default information originate no summary. If you do this, you're going to get a very weird situation in which you're going to get both type 3 and type 7 generated. Now, obviously, it will be type 3 that will be used by other routers, because it will win over type 7s, but they are both going to be generated.